I have the previous year discrete mathematics question paper with me, and this is the December 2024 question paper, and I'm going to solve the unit 4 of this question paper. So let me quickly take you to the unit 4 of this question paper. And in the unit 4 we have two questions, that is question number 8 ABC and the question number 9 ABC. We are supposed to answer any one of them, so I'm going to solve both of them over here. For the purpose of explanation, I have taken this question paper and solved it in Microsoft Word. So all my explanations will be in the Microsoft Word. So let me start with the first question, that is question number 8A. The question number 8A is as follows. What are the degrees and neighborhood of the vertices in the graph displayed? So I will switch to the Microsoft Word over here. So this is the question that was given. We are supposed to find the degrees and the neighborhood of all the vertices which are shown in this graph. A quick recall of what is neighborhood and what is the degree. Neighborhood NV of a vertex V is the set of vertices that are directly connected by its edge. So what is the meaning of that is, suppose if I take the vertex A as my reference, and what are the neighborhood of or the neighborhood of vertex A is all the vertices which are directly connected by an edge. So this is directly connected by edge, this is directly connected by edge, and that is what is the neighborhood. What is the degree? Degree is the total number of edges connected to that particular vertex. So let me show you the answers for this particular question. So this is the graph that is given to us. Let us start with the vertex A now. So vertex A, if you look at the vertex A, what are the neighborhoods of vertex A? You know very well the vertex B and F are directly connected to the vertex A. So the neighborhood of this vertex A is B and F. What is the degree? There are two edges which are connected, so the degree will be 2 over here. So let us look at the vertex B now. So if I take the vertex B here, so if I take the vertex B here, B is connected to A, B is connected to C, B is connected to F, B is connected to E. So this is ACEF will be the neighborhood. And how many edges are there? 1, 2, 3, 4. So altogether 4 edges will be there. So let's look at the vertex C here. So if you take the vertex C here, how many vertices are connected to it by a direct edge? One is B, the other one is D, next one is F. There is an edge over here, you can notice there is an edge here, and the last one is E because there is a edge here. So we have B, D, E, F. How many edges are there? 1, 2, 3, and this one is 4. So altogether we have 4 edges, and that is what is called as the degree. Let's look at the vertex D here. So vertex D, you notice that it is connected to only one of the vertex, and that is C, by an edge. So there is only neighborhood of D is only one, that is C, and it is connected by one edge, so its degree is going to be 1. Let us look at the next edge E over here. So if you take this edge E here, so E is directly connected to B, E is directly connected to C, and E is directly connected to F. So it is BCF are its neighborhood, and there are 3 edges which are connected to it. So this is going to be, degree of it is going to be 3. Now let us look at the vertex F here. So if you look at the vertex F here, F is connected to A, F is connected to B, F is connected to C, F is connected to E. So it is connected to A, B, C, E. These are the neighborhood of the vertex F. And what is the degree? 1, 2, 3, 4 is the degree of this particular text. Now let us look at the last vertex, that is G. This is completely isolated, so there is no neighborhood. So the neighborhood is empty set and the degree is 0. So this is the first question. Let me take you to the second question. Second question is convert the following tree into a binary tree. So this is the ordinary tree with multiple number of children. So every node can have more than 2 childs. That is the reason it is not a binary tree. In binary tree, any node can have maximum of 2 children. So in this case, if you look at this node, it has more than 2 children, and if you consider this node for that matter, that is node number 5, more than 2 children, so this is not a binary tree. How do I convert that into a binary tree? I will not explain the details about the binary tree and other type of trees over here. So what is that you are supposed to do it? See, please don't do this on your question paper. Remember, scribbling anything on the question paper is considered as malpractice, and you will be debarred if you are found writing anything on the question paper. So use the answers paper itself for solving the questions. Don't use the question paper for doing the rough work. So what is the rough work that you are supposed to do it? Draw the graph that is given over here. Draw this tree as it is. Carefully draw it on your answer script, not on the question paper. And what is the thing that you are supposed to do it? So take the first node over here. So this is the first node. Mark the left hand side, the left child as L. Go to the second node, mark its leftmost child, only one child, leftmost child as 1. Go to the next node, mark its leftmost child as L. Go to the next node. If there are no leftmost node, leave it as it is. Go to the next node, 5, node number 5, mark its leftmost child as L. So you are only marking the leftmost child. You just mark the leftmost child as L. Now take your pencil, and then you have marked everything as L. These are L were there. Now go to the sibling of this node. So sibling is all the nodes that have the same parent as this child. So the child number 2, if you look at all the 3, 4, 5, all of them have the same parent, and the parent is 1. So all of them must have the same parent. You cannot take the other one. So you take this 2 here. You have marked all of them as L. You take this 2 and use your pencil and draw from this 2 to its sibling. Remember, it must have the same parent as the current child. So draw an arrow and mark it as R. Again, draw an arrow, mark it as R. Draw an arrow, mark it as an R. So that means all its siblings are connected by R. Remember, they must have the same parent. That is very important. Next one, go to the next child over here and then mark its sibling with the arrow and R. Remember, 8 is not the sibling of 6 because the parent of 6 is 2, parent of 8 is happens to be 3. So they are not connected with each other. So it is not its siblings. So only siblings are marked here. So you mark the sibling as R. Here, if you notice, for this 8 there is no sibling. In that case, leave it. 4 does not have the left node as well as the right node. Just leave it as it is. Go to the 5. You have marked the 9 as the leftmost child, and then from the 9 you have 3 siblings, that is 10 and 11. Mark them with R. So this is what you are supposed to do it. Do it on your answer script, not on the question paper. Now start with the parent, that is 1. So you mark the parent as 1. Use now first you are going to go with the leftmost child here. So L, you traverse along the L. What you get is 2. Mark it as 2. Again go to the L of this 2, that is the left child of 2, and mark it as a 6. Now with this you don't have anything. 6 does not have any children, so go to its sibling. So who is there to the right? R means to the right of it. Who is there to the right of 6 is 7. So mark 7 as the right of 6. So the 6 is over, 7 is over. You came up to, so you came up to the 2 here. So 6, 7 is over, 2 is over. Now you have traversed the left child of 2. Now go to its right child. So you go to the right. Who is there to the right of 2 is 3. So to the right of 2, you mark it as 3. So to the right of this 2, you mark it as 3. Now start with the 3. Start with the 3 now. Who is there to the right of 3 is 4. To the right of 3, you have 4 here. Okay. Now to the right of 4, you have 5. So to the right of 4, you have 5. So you mark that to the right of 3, you have 4. To the right of 4, you have 5. Now start with the 3 here. 3 has a left child. So 3 has the left child. So this 3 has the left child. And that child is 8. So you mark it as 8. Now coming to the 4 here, 4 does not have any children. So you just leave it as it is. So there is nothing you can do about it. Go to the 5 here. So 5 has the left child. So what is the left child of 5? So left child of 5 happens to be 9. You just mark it as 9. Now come to the 9. 9 has the right child 10. So just mark the 9 has the right child as 10. So you mark it as right as 10. 10 has the right child as 11. 10 has the right child as 11. So when you have done this, that means you have traversed the entire tree here. So nothing is left over. You have used all the nodes here. So that means you have created a binary tree. You notice that for any node, the maximum number of child will be 2. It can be at maximum you can have only 2 children. So this is the binary tree of the given tree. So this is what is the question, and this is the solution for that question. Let us go to the next question, and the next question is with lengthier question. So what is given over here? Okay, give a state diagram for finite state automata. So we are supposed to draw a state diagram for finite state automata of a device that determines modulo 3 counter. So what is the meaning of saying modulo 3 counter? Means this counter will give the remainder of any number that is divided by 3. So you take any number, divide by 3. So what are the possible remainders that you can get? So for example, if the number is 33, so divide it by 3. So 3 will divide it many times, but what is the remainder? So 3 will divide it 11 times. So 3 will divide it 11 times. Remainder is 0. So remainder is 0. Now let us look at one other number. I will take the number as 91. So given number is 91, divided by 3. So how many times 3 will go? 3 will go 3 times into, so 30 times it will go. What is the remainder? Remainder 1 is remaining. So this is 3 into 3 is 90. So 90 plus 1. So remainder will be 1. So you have last time the remainder was 0. This time the remainder happens to be 1. Let me take one other number. Okay, say, let's say 65. Let me divide it by 3. So when I divide it by 3, what is that I'm going to get? So if I divide it by 3, okay, what is that I'm going to get over here? So if I divide it by 3 over here, okay, so let me go here. Where is the mouse pointer? Okay, so it will go 2 times, it will go 1 time, and remainder will be 2. So if you know, this is a 63 plus 2 will be 65, so the remainder will be 2. So whenever you divide a number, so when you divide a number, the remainder that you will get is either you will get a 0, or you will get a 1, or you will get the remainder as 2. You won't get anything about this. So remainder, you cannot get the remainder as 3, because 3 can divide 3, and you know very well, in that case the remainder is 0. 3 will completely divide 3 by itself, so remainder is 0. So the remainder is either 0, 1, or 2. So that means to say that this counter can either give you 0 or 1 or 2. It cannot give you more than that. So and that is what is mentioned over here. So what is mentioned here is the counter will receive 3 inputs, that is either 0, 1, or 2, and it produces either 0, 1, or 2. 0, 1, or 2. That means 3 output it is going to produce. So that means to say that if you have a counter, here, whatever is the counter, you give 3 inputs here. Either the input is 0, next is input is 1, the next is input is 2. This counter is going to give you the output as either 0, 1, or it cannot give you more than that answer. So that is what is the meaning of saying counter will give you, counter will take the receive the input in the sequence 0, 1, 2 as an input, and it is going to produce the output as 0, 1, 2, 3. So this is the meaning of it. So counter is given only this value, that is the 0, 1, 2, and it is going to produce 1, 0, 1, 2 as the output. So this is what we are supposed to do it. And what is that we are supposed to do? Very important thing. We are supposed to draw the finite state diagram. That's all. We are supposed to draw the finite state that is the state diagram for this finite state automata. So let's go ahead and let's do that thing. What is given over here is the output must be equal to the modulo 3 sum of the inputs. So that means to say that if you have 3 inputs, so if you let's look at this one, so 3 inputs are there, so the output that is produced is modulo 3. So that means to say that it's going to give you mod 3 output. So the input here can be either 0 or 1 or 2. Whatever it does is whatever input you are going to give, suppose if you give all the 3 inputs 0, 1, 2 as the input, so you are going to sum them. So that is what is given over here. So here if you notice what is given is a modulo 3 sum of all the 3 digits. So that means to say that if you give the value as input as 0, so it's going to say 0 plus 1 plus 2 divided by 3, and it's going to give you the remainder. You know very well the answer of this is 3. 1 plus 2 is 3. 3 by 3, so result will be 0. Suppose if you have the counter, so let's say suppose if you have let me just draw it over here. Suppose if you have a counter with the 3 inputs, okay, so I'm just giving you an example. This is 2, this is 2, this is 2, all the 3 inputs are 2. What is the output? So output is 2 plus 2 plus 2 divided by 3. So this is 6 by 3, and this is happens to be Remainder, remember I am not interested in the quotient, remainder is 0. 3 will divide 2 times, remainder is going to be this one. Suppose let's say, again let me just give you an example. Again I'm giving you one example over here. So you have an counter over here, 3 values are there. So let me say the first input is 2, second input is 1, third input is 2. What is the output in this case? This is 2 plus 1 plus 2 divided by 3. So this is happens to be 5 by 3. 3 will divide it to 1 times, 2 is the remainder. So the output will be 2. Hope you are able to get that thing. We are supposed to draw the state diagram for this one. So let me quickly shift to the Microsoft Word over here. And what is given over here is we are supposed to draw it. So we must have the initial state and we must have the some final state. In this case the final state could be any one of them. The initial state itself can be the final state. So the initial state, let me start with the initial state. Initial state, the sum will be 0. What is the meaning of saying initial state the sum will be 0 is our counter initially will give you the answer as 0. So this is a S0 state. I am marking it as S0 state. So what are the possible output you are going to get? So either you are going to get a S0, that is sum is 0, S1, that means the remainder is 1, S2, the remainder is going to be 2. So when I add 3 inputs, say T1 plus T2 plus T3, so suppose when I add 3 input and divided by 3, the remainder can be either 0, the remainder could be either 1, or the remainder could be either 2. So one among them, and that is what is being shown over here. 3 states are there. Either the when you make the mod 3 of the sum of the input, either the state is 0, or you are in the output state 1, that is S1, or you are in the state S2. Okay, so what is the input that you are going to give? 3 input you are going to give. So what are the 3 inputs? So suppose if you have the machine over here, suppose you have the machine here, so you get 3 inputs for this one. So either all the inputs are 0, or all the inputs are 1, or all the inputs can be 2, or anything. First input is 0, second input is 1, third input is 2, or first input is 2, second input is 2, the third input is 0. Any possibilities are there, but what are the possible output that you are going to get is only 3 states. And what are these 3 states that you are going to get is either S0, S0, S1, or S2. All the only 3 states you are going to get it there. Okay, hope you are able to get the logic of this particular thing. So we will start with the current state, and we will see what is the transition that we are going to get. So suppose there initially you are at S0. So let me say initially you are there at S0 state. Okay, so S0. So that somehow you give some input, you are there in the S0. What is the meaning of saying S0? So sum is 0. This is the state. Suppose for this you are giving the value S1, the input 1 is 0. Okay, input 2 is 0, input 3 is also 0. So what is the status? 0 plus 0 plus 0, 0 plus 0 plus 0 divided by 3. So again the remainder is going to be 0 itself. So that means you are there at the same state. Okay, and that is all the possible states are being shown over here. So this is what is the marking that is been shown over here. So if the current state is S0, you give first input is 0. That means you are there in the current state. Yes, sum is 0. You give 0 as the input. It's not going to change its state. So you are still in the S0 state itself. Suppose you are there in the current state. Let me say, suppose say you are in the S0 state, and for this you give 1 as the input. So what is going to be there? What is 0? So any one of them is 1, let me say. So 0 plus 1 plus 0. Let's say you can say 0 0 0 plus 0 plus 1, anything you can say, but one of them is 1. So divided by 3. So this is 1 by 3. 3 cannot divide 1, remainder will be 1. That means to say that you are in the this state, which is the state S1 state. So you are going to transmit from S0 to S1 state if input is 1, and that is what is being shown over here. So if the input is 1, so from S0 current state you will go to the S1 state. Okay. Now suppose say you are in the S1 state. So let me just say you are in the S1 state. You are in the S1 state. Now, okay, you are in the S1 state. Now you are going to give the input as 2. What will be the output? What will be the output here? So this is, see, remember you are in the S1 state. What is the meaning of saying S1 state? You are already in the 1. Okay. So for that, okay, if you are adding, if you are there at S1 state, for this if you add 2, what is the meaning of this? This is 1 plus 2 by 3. So this is going to be, remember, I am not interested in the quotient, I am interested in the remainder. So this is going to be 3 by 3. Remainder, not the quotient, remainder is 0. Suppose say you are in the S0 state. So this is what is the meaning. You are in the S0 state. You are in this state, S0 state. Suppose if you are in the S0 state, for this if you add 2, what is going to happen? 0 plus 2 by 3. So this is 2 by 3. 3 cannot divide 2. So the remainder happens to be 2. So 3 goes 0 times, remainder is 2. And that is what is given over here. So if you give the input as 2, that means you are in this state. Now let us try to solve the other option. So let us go to the second option. Suppose you are in the S1 state. So your current state is S1. So your current state is S1. For this you add 0 to it. 1 plus 0. So I am going to say current state is 1. So let me just write here. 1 plus 0 divided by 3. You know very well. 1 plus this is 1 by 3. 3 cannot divide, the remainder is 1, and that is what is the meaning. So suppose you are in the state 1. If I give the input as 0, you will be in the state 1 itself. Suppose you are in the state 1, that is S1. You give the input 1 to this one. So 1 plus 1 divided by 3. So what is 1 plus 1 divided by 3? So this happens to be 2 by 3. What is 2 by 3? 3 cannot divide. 3 will divide 0 times. 2 will be the remainder. That means you are in the S2 state. So if you give this is the mouse pointer. Okay, if you give 1 and 1 as the input, you are in the state 2. Okay, so you are in the state 1 now. So you are in the state 1. So this is 1. If you give the input as 2, what is going to happen? So 1 plus 2 is 3. 3 by 3, 3 will divide 1 time. 0 is the remainder. That means you are going to come back to S0 state, not S1, S0 state. So if you are there, at S1 state, and if you give the input as 2, so this is going to be 1 plus 2 divided by 3, 3 by 3. Remainder, remember we are talking about modulo 3, that means we are interested in the remainder, not the quotient. So the remainder is 0. Now let us look at this state. Your current value is 2. 2 plus 0. 2 plus 0 is 2 itself. 2 by 3, the output will be 2 itself. That is state 2. You are in the 2 state. 2 plus 1 is 3. 3 divided by 3, remainder is 0, and that is what is given over here. So where is here you are in the 2 plus 1, the answer will be 0. Remember, this is remainder is 0. Now let us look at the next state. Your current state is 2. 2 plus 2 is 4 divided by 3. 3 goes 1 time, so 1 is the remainder, and that is what is mentioned over here. So this is 2. Your current state is 2. You give 2 to this, 2 plus 2, so 2 plus 2 divided by 3, the next state will be S1. So this is what is given over here. Now this is what is the state diagram, and this is what is the transition table. Look at this transition table and then start drawing the value. So you start with the ES0, that is what I said, the initial state is ES0. You start with the S0. So you start with the S0. For this S0, if the input is 0, you come back to the same state, that is S0. So you come back to the same state, S0. So from S0, you give the two things that are shown over here is, first one is the input, the second one is the output. So if you give 0 as an input, the output will be 0 itself. So you are going to come back to the same state. Let us look at the next transition. You are in the S0. Okay, you give 1 as the input, you will go to the S1. So you give 1 as an input, you will go to the S1. From S0, you will go to the S1. Now you are in the S0 state. You are in the S0 state. You give 2 as an input. So 0 plus 2. So this is 0 plus 2. Remember, 0 plus 2 divided by 3. Remainder is 2 itself. So you give in the S2 state, you give 2 as the input, you will get 2 as the output. You will be there at S2. So this is for the state S0. Next, let us take the S1 state. So for the S1 state, if you give 0 as an input, the output will be same state S1 itself. So for S1, if you give 0 as the input, you will be there in the same state. So next one is we are there in the S1 state and we are giving the input as 1. So 1 plus 1, so this time this is going to be, the value is going to be 1 plus 1 divided by 3, that is 2 by 3, and you know very well remainder is 2, that means you are in the S2 state. So if you give S1, you give 1 to the input, the output will be 2 and you will be in the S2 state. Now let's look at the next option, and that is the S1 plus, that is 1 plus, so remember sum is 1 here, 1 plus 2 is 3, you know very well, 1 plus 1, 1, let me take 1 plus 2 divided by 3, 3 by 3, it 3 goes one time, remainder is 0. So that means you are in the S0 state. So you will come back to S0 state. So if you are in the S1 state, and if you give 2 as an input, you will come back to the 0 state, and that is represented here. Okay, now let us go to the last option over here. And what is the last option? S2. If you give 0 to this S2, that means what is the meaning of this? The previous sum is 2. 2 plus 0 by 3. So 2 by 3, 3 goes 0 times, 2 is the remainder. So that means you are in the S2 state itself. So that means to say that if you are in the S2 state and if you give 0 as the input, you will retain in the same state, and that is what is there. You are in the S2 state, you give 0 to it, you will be there in the same state. So that is what is mentioned over here. Next one, let us look at the next one. You are in the S2 state, you give 1 as an input, So this is going to be 2 plus 1. So this is your current sum is 2. Current sum is 2. 2 plus 1 divided by 3. This is 3 by 3. 3 goes one time. 0 is the remainder. That means to say that you are in the S0 state. So from S2 state, if you give 1 to it, you will come back to the S0 state. From S2 state, if you give 1, you will come back to S0 states. From S2 state, if you give let me just slightly push it up. So you are in the S2 state, you give 1 to it, you will come back to the 0 state. So that this is represented by this arrow. Now let us look at the next option. You are in the S2 state, you give 2 to this one. So what is the meaning of that? Current sum is 2. Current sum is 2. For this you add 2. 2 plus 2 divided by 3. That is 4 divided by 3. 3 goes one time. 1 is the remainder. So that means to say that you are in the, you will go back to S1 state. So here you are there in the S2 state. You give 2 as an input. You give 2 as an input. Okay, you will come back to the S1 state. You will come back to this S1 state, and this is indicated by this arrow. So this is the drawing that you can have. Now there is other thing that you can do is for all of them, all these circles, because they are also the final state, you can mark them as the final itself. I will not mark them as a final because these values keep on changing it. Now for a given counter, this value can be the final. So for a given input, this can be final, but I will not mark them because these values keep on changing, because as the sequence changes, these values will keep on changing. So this is the state diagram for the question that is asked over here, that is the modulo 3 counter. Now let's look at the next question. Let me go to the next question over here. And what is the next question? Question number 9 is, what are the degrees and the neighborhood of the given vertex that is displayed in this graph? So let us go back to Microsoft Word over here. Let me just go to the Microsoft Word here. So this is the graph that is given over here. This graph, extra information, remember this is not required. You don't have to write this thing in the examination. This is called as a pseudograph because it contains a loop as well as there are multiple edges between the given vertices. That is why it is called as a pseudograph. Now, what is the neighborhood of a given node? You know very well. Neighborhood are the vertices which are directly adjacent to the given vertex. So what is there in the neighborhood of A? Neighborhood of A contains B, C, B, D, and E. You are already familiar with that option. What is a degree in this case? Remember, whenever there is a loop, you will count this as a 2. Degree, you count it as 2. So what about this one? Because it is a loop, you will count it as 2. Remember, whenever there is a loop, you count it as 2. So you have to remember that thing. Now with that idea, let us go ahead and let us solve the question now. So let us start with the edge, that is a vertex A here. Vertex A, directly connected edges. So B is connected, D is connected, E is connected. So the neighborhood is BDE. Okay. What is the degree of it? B, from A to B, the degree is 1. From A to D, degree is 1. From A to E, there is a loop here. So a loop is considered as a degree is 2. So there are two multiple loops, multiple edges are there. So it is considered as 2. So what is the total degree? Total degree of A is 4. Now let us look at the B here. So vertex B, what is there in the neighborhood of this one? Directly connected edge, one is A, then other one is C, directly connected. You see it is directly connected. D is also directly connected, E is also directly connected. So this is A, C, D, E are in the neighborhood of this one. What about the degree? This is 1, this is 2, this is 3, this is 4. Remember, loop is considered as 2, so you add them. So you add all of them. 4 plus 2, remember this, every loop is considered as degree 2. loop is considered as degree 2. So you add 2 to this one. So this is a to b 1, b to c 1, b to d 1, b to e 1, b to b it is taken as 2. So you take the loop as 2. So you have counted 1 plus 1 plus 1 plus 2, that is going to be 6 is the degree. Now let us look at the next one, C. There is only one node, that is one vertex that is connected. So this is C to B, only one. Neighborhood of C is only B. Degree is only one because there is only one that is connected. Let us look at the D here. So D, how many are there? D is connected to A, D is connected to A, D is connected to B, D is connected to E. So this is A, B, E. What about the degree? For D to A, degree is 1. D to B, degree is 1. D to E, there are 3 edges are there. So you take it as 3. So altogether, so the degree happens to be 3 here. So there are 3 edges are there, so you count it as 3. So add all of them, 1 plus 1 plus 3, that happens to be 5. What about the next one, edge E? So edge is connected to A, connected to B, connected to D. So neighborhood is ABE. For A to E to A, there are 2 edges, so you take 2. For E to B, there is only 1. For E to D, there are 3 edges are there. You take it as 3. So 2 plus 1, 3, 3 plus 3 happens to be 6. So this is the degree of that. Let us look at the next question. Next question is, this is the question. Construct a dual graph for the given map and write the chromatic number. So what is the meaning of saying constructing a dual graph? So take all the region, all the planes over here. So all these regions as edges. So you take B edges A, B, C, D, E, F, G. So you take all of them as the edges of the graph. So all these regions that are shown over here, take them as edges. So this is vertex A, this is the vertex B, this is the vertex C. So all the planes are taken as the vertex of the graph, and then say whether they are connected, they are adjacent to each other. A and B are adjacent to each other. So you draw a line from, or you draw an edge between A and B. Then A and C, you see that they share a common edge here. So you draw an edge between A and C. A and D, if you look at here, A and D, there is a common, they are adjacent to each other. So you say A to E, there is a edge here. Okay. Next one, A to E, you notice that there is a common edge here. So you just draw a common edge to A to E here. Okay. Now start with the B. B to A is already taken care. B to C, there is an edge. So you draw an edge between B to C. B to D, there is a common edge here, that is they are adjacent to each other. So you draw B to D, an edge there. So that is done. Let's start with the C. C to A is already there. C to B is already there. C to D, so there is a connection between C to D. You draw an edge there. Now coming to D here, D to A, D to B, D to C is already taken. D to A, D to B, D to C is already taken. D to G, D to F, D to E, you have to draw it. So D to G, D to F, D to E. You draw it, edges there. So it is done. Let us go to the E here. E, you notice that E is adjacent to D, E is adjacent to A, E is adjacent to G, E is adjacent to F. So E is adjacent to A, you draw. E is adjacent to D, you draw. E is adjacent to F, you draw an edge. E is adjacent to G, you draw one more edge. So you draw wherever there is they are in the neighborhood, that is they are connected by a plane, that means you just draw a edge there. Coming to F here, F is connected to D, G and E. F is connected to D, F and E. They are connected to E. Let us look at the G here. G is connected to D, G is connected to F, G is connected to E. G is connected to F, G is connected to D, G is connected to D, G is connected to F, G is connected to E, G is connected to F, G is connected to E. And that is what is the map that you have created. So you have the dual graph of the given map. This is the dual graph of the given map. And what is the chromatic number? So chromatic number for this is 4. What is the meaning of saying chromatic number? Least number of colors that are required for drawing this graph. You need 4 colors over here. So let us assume that you're going to use this 4 colors to draw this graph. So I will assume that I will start with the first one here. So I will start with the node A here. That is the node A. I will where is this node A. So I will draw it with the red color. So one color is over. Node B cannot be red color because you can't have the two adjacent nodes with the same color. So I will take the node B as a blue in color. So let me take the color as blue here. So blue color. Now red is you cannot have the red color because C is connected to the A by red color. So this is also red color. Actually we are using the we are supposed to use the edge to be drawn as the color, but I will take it as this region. B is blue in color. Next I am going to mark this one as C as green color. So remember the directly if you take this edge over here, this is red in color. You can't have the same color here. So I can't have the red color here because red and red is not allowed. So if this is red, this one must be different color. If this is green, this one must not, you cannot have it as a green. Okay. Now coming to the mm, D over here. So I cannot connect draw the I can have the red here for D because D is directly connected to red. I cannot have blue here because it is directly connected to the blue. I cannot have green here. So let me take some other color. So let me take this one, this color as yellow as my color. So this now you notice that they are not connected to each other. So no two sides of the edge have the same color. Now coming to the next one, E. Now you notice in this case E. Now E is you you cannot have E as a red color because it is directly connected to this. You cannot have the yellow as the color because yellow is directly connected over here. I can have green here because remember green is not directly, there is no edge here. So I can draw this one as green here. Okay. Now next one, you notice F here. F cannot be yellow in color. F cannot be green in color because they are there here. I can take this one as a red or a blue or any other color, but not this one. Okay. Now coming to the next one, you cannot have G cannot be yellow, G cannot be red, G cannot be green. I can take this one as a blue color. So you notice that the graph can be colored using only 4 colors, so that is why the chromatic number of this graph happens to be 4. Okay. Now the next one that is given over here, the last question that is coming on this one is convert the given NFA into DFA. How can I convert NFA into DFA? So this is the given graph that we are supposed to convert it into NFA. So let's go ahead and let's do that thing. So what is the first thing that we are supposed to do? We first draw the transition table for this one. What are the inputs that you have? So input that I have, the state that I have is Q0, Q1 and Q2. So state is Q0, Q1 and Q2. Q0 is the starting state, I am marking it. Q2 is marked as the final state, so I am marking that one here itself. What are the different inputs that you have? Either you have the input as A or the input as B. So there are only two inputs are there, A and B. Now let us first draw the transition table for this given NFA. So let's start with the first one, Q0. If the input is A, for the Q0, if the input is A, it will come back to Q0 itself. So it will come back to Q0 itself. Q0 with the A, it will come back to Q0 itself. Next one, Q0 with the A, it will go to Q1. So Q0 with the input A, it will come back to Q1. Done. Next one, now let's start with the Q0. So Q0 with the B, so Q0 with the B will go to Q2. Q0, it will go to Q2. Q0 with the input B, it will go to Q2. Done. Let us look at the Q1 state. So Q1 state with the B, it will come back to Q1 itself. So Q1 with the B, it will come back to Q1 itself. Q1 with A, it will go to Q0. Q1 with A, it will go to Q0. So that is what is shown over here. Let us look at Q2 here now. So Q2 with A, if you notice over here, all of them are B states. So with A, it will go to dead state. So it will not go anywhere. Let us start with the Q1 here. So Q1 with the Q2 with the B, it will go to Q0, it will go to Q1. So Q2 with the B, it will go to Q0, it will go to Q1. So that is what is mentioned over here. Now you have the transition table with Q for the NFA. Using this, you have to draw the transition table for DFA. So how do you go for the non-deterministic to deterministic? So first one, write as it is, that is state input, only two inputs A and B, and we start with the first one. Remember from the your NFA transition table, remember you must note which you must know which is the starting state. So this is given over here. Starting state is generally marked with an arrow. So either double added arrow or just a dark arrow that states that it is the starting state. So make note of this starting state and copy it as it is to the DFA. So this one, take the starting state, copy it as it is to the DFA transition table. So this is direct copying. Now onwards you have to start doing it. Now here you have two states now. One is Q0, Q1, other one is Q2. Now you have to find out what are the possible transition for this. So you start with the, remember this you have taken it directly from here. You've taken it and you are writing as it is here. Now once you have written it, you have to write this thing now. What will be the transition for Q0 and Q1? What is the transition for Q2? So let us start with the transition for Q0, Q1. So you write the state is Q0, Q1. For this state q0 q1, if A is given as the input, what are you going to get? And if B is given as an input, what are you going to get it? How can I get this one? So there are two things are there, q0 and q1. So let's look at this one, q0, this one, q1, this one. So go to the previous transition table. Now you have to combine them together, q0 q1. So union of this one, q0 q1 together. Okay, q0 q1, if the input is A, what are the things you are going to get it? Q0 q1 and q0, remember you are making the union, you are not repeating it. So the state is q0 q1, repeated things you just leave it, q0 q1. So when the input is A, this will be the state q0 q1. Next, q0 q1, if the input is B, what you are going to get? First, for q0 you get the input as q2. For the next one, q1, you get the input as you get the state as q1. So you combine them together, q1 q2, you write one. So q0 q1. For the state B, this is going to be q1 q2. Done. Now let us start with the state over here. So among them, q1 was the starting state, you leave it. You have taken care of q0 q1, so this is done. Now how many are not done? So in this case this is done, this is same as the previous one, this is done. What is not done? q2 is not done, q1 q2 is not done. So let us take the q2 now. So let's start with the q2 now. So you start with the q2. Okay, you start with the q2. Now q2, go to the previous table, q2. For q2, if you give A, you will go to the dead state. So for q2, if you give A, you will go to the dead state. Dead state, I am marking it as the null here, so that is a dead state. Okay. Next one, q2, if you give B, the output is q0 q1. So q2, if you give the input as B, you are going to go to the q0 q1, write it as it is, whatever that is given over here. Now again look at what are the things that are being taken care. So you have taken care of this, it is done. You have taken care of this, this is done. Okay, this is same as the previous one, this is same as the previous one. What is not done is q1 q2, null is also not done, dead state is also not done. So let us start with this one, q0 q1. So let's start with the q0 q1 q2. So let's start with the q1 q2. So I'm going to write a q1 q2 here, q1 q2 here. So let's write a q1 q2 here. Now you have to look at the previous table. So let's look at the previous table here and identify q1 and q2. Remember, this is the place you are going to identify. So this is the one that you are going to use it. So for q1 q2, if the transition is A, so if the transition is A, you get q0, and for q2 the transition is a dead state, leave it as blank. So this is q1. So you are going to get it, if you make the union, it's going to be q1. Now let's look at q1. If the transition is B, if the input is B, the transition will take you to q1. q2, if the input is B, it will take you to q0 q1. Remember, q, if it is anything is repeated, you just use it only once. So the output in this case is q1 q0 q1. q1 is repeated, so you just say q0 q1. So for the input B, it's going to be q0 q1. It's done. Now if you look at the table now, q0 q1 is taken care, q2 is taken care, this is already taken care, q1 q2 is taken care, q0 q1 is taken care, this is taken care, q0 is already taken care. What is not taken care is the dead state. So the dead state, you just put a phi here. Remember, from the dead state, it will not take you anywhere else. Dead state is always dead only. So if you give A, input, you are going to come back to dead state only. For the dead state, if you give B, you will come back to the dead state itself. So this is it. Now look at this one and you have to identify the input, the initial state and the final state. Remember, in this case, in the previous NFA, the initial state was Q0. So mark Q0 as the initial state. Q2 is the final state. So wherever in the state Q2 is there, mark them as final state. Q2 is final state. Here it is there. Here you have Q1, Q2. Again, because Q2 is there, this is going to be the final state. Both of them are going to be final state. So whenever you find Q2, wherever you find Q2, just mark them as final state. So here Q2 is also final state. Q1, Q2 is final state because Q2 contains, this contains Q2. So wherever you get the Q2, you are marking it that state as a final state. Now start drawing the transition table. So we start with the Q0. So you start with the Q0, mark it Q0. Q0, Q1, mark them Q0, Q1, put them in the square bracket. Then Q2, mark them as Q2 because it is a final state. You put double circle for that. Then Q1, Q2, double circle for them. Remember, you don't have to draw it in this way also. You can arrange them in any way you want it. So I have just arranged them in one possible way. And you have the dead state here. Remember, I have taken the dead state as pi here. Some people will like to take this one as Q next state, Q1, Q2, and some people will call this as Q3. You can call it with any symbol you want. So some people, instead of this, they will call it as Q3. You call them as Q3. In that case, everywhere you have to make it as state as Q3. Okay, every state you make it as Q3, but I have taken it as a dead state. So I will use the same symbol. It is just a symbol that you are using. You are not making any complication there. So let's come back to the states there. So mark all the states. Mark all the states. So Q0, Q0, Q1. Anywhere you can place it. You can place Q0 here, Q1 at this place. Anywhere you want, you can place it. Arrange them in any way you want it. You have full sheet of paper with you. You can place it anywhere you want it. But say to it that it is easier for you to connect the edges there. So otherwise, it will be a difficult task for you to do it. So you mark Q0, Q0, Q1. Put them in whenever you have two symbols, you put them in a square bracket. Then Q2, you have marked it. Q1, Q2, mark it. Dead state, you mark it. So done. Okay, for the final state, remember initial state you mark it with the two arrow. Final state you have to use two circles, that is double circle. Draw double circles around it. Now draw the transition from Q0. If you give the input as A, you will go to Q0, Q1. So from Q0, if you go to the, if you give the transition as A, you will go to this state Q0, Q1. You will go to this state. So this is for the input A. 1 is done. From Q0, if the input is B, you will go to the Q2 state. From Q0, if the input is B, you will go to Q2 state. Done. Now let's go to this one Q0, Q1, Q0, Q1, this state. If the input is A, you will go to Q0, Q1. Q0, this is Q0, Q1. So if the input is there, you will come back to the same state. That means it is a loop. So you will come back to the same state. So from the A, you will come back to the same state. If you give A, you will come back to the same state. Next, from Q0, Q1, if the state is B, you will go to Q1, Q2. So if the state is if the sorry, not the state, if the input is B, you will go to the state Q0, Q1, Q2. If the input is B, you will go to Q1, Q2. So if the input is B, you will go to Q1, Q2. Done. Next one, let's go to the next state, that is Q2. So from the Q2, if the input is A, you will go to dead state. if the from Q2, if the input is A, you go to the dead state. So you go to the dead state. Just draw an arrow there. Okay, then from Q2, if the input is B, you go to Q0, Q1. So from Q2, if the input is B, if the input is B, you go to Q0, Q1. You go to Q0, Q1. So you draw an edge there. So done. Okay. Now let's look at the next state. Q1, Q2. So Q1, Q2 from here. If the input is A, you go to Q0 state. If the input is A, you go to Q0 state. Just draw an arrow there. So done. If the input is B, you go to Q0, Q1. If the input is B, you go to the Q0, Q1. From here, draw an arrow. You're done. From the null state, you know very well whether it is A or B, you will come back to the same state. So for A and B, you come back to the same state, and that is what is the conversion of NFA. This NFA has been now converted into DFA. So this is what you are supposed to do it. So I have solved the unit 4 questions there. So these are the 3 questions which are there. Other questions I will solve it in the subsequent videos. Thank you for your interest. We will meet again in the other exercises. Thank you.